Imagine breathing in tiny plastic particles every time you take a breath. It sounds like a sci-fi nightmare, but it's a growing reality. New research from the University of Manchester is sounding the alarm on micro and nanoplastics in our atmosphere. And it's far more widespread and complex than we ever imagined. Scientists are now calling for urgent global action to tackle this invisible threat that could be silently impacting our health and the environment. In a groundbreaking review published in Current Pollution Reports, researchers have delved into how these microscopic plastic fragments, some smaller than a speck of dust, enter the air, where they originate, and how they travel across continents. But here's where it gets controversial. Despite the rapid growth in awareness, our understanding of this issue is still riddled with gaps. Inconsistent measurement methods, limited data, and oversimplified models have left us with more questions than answers. One of the most startling revelations: we don't even know how much plastic is entering the atmosphere. Estimates range from less than 800 metric tons to a staggering 9 million metric tons annually. That's a difference of over 10,000 times. And this is the part most people miss. We're not sure if these plastics are primarily coming from land-based sources like road traffic or marine sources like sea spray. This uncertainty makes it nearly impossible to assess the true global impact. Lead author Zhonghua Zhang puts it bluntly: the scale of uncertainty is alarming. Plastic pollution isn't just an eyesore, it poses serious risks to human health and ecosystems. To protect ourselves and the planet, we need better data, more accurate models, and global coordination. But how do we get there? Every year, over 400 million metric tons of plastic are produced globally, much of which ends up as waste. Over time, this waste breaks down into microplastics, smaller than 5 millimeters, and nanoplastics, smaller than 1 micron. These particles are everywhere, in the air we breathe, the oceans we rely on, and the soil that grows our food. They can travel thousands of miles in just days, reaching even the most remote regions like polar ice caps and mountain peaks. Yet, despite this, key questions remain unanswered. To bridge these gaps, the researchers propose a three-pronged strategy: expanding and standardizing global observation networks, refining atmospheric modeling, and leveraging artificial intelligence (AI). AI can be a game-changer, says Fei Jiang. It can analyze fragmented data, uncover hidden patterns, and integrate information from multiple sources, but it needs high-quality data to work effectively. This integrated approach, they argue, could revolutionize how we tackle the plastic pollution crisis. But here's the controversial question: are we doing enough to address this issue? With plastic production showing no signs of slowing down, is monitoring and modeling sufficient, or do we need radical changes in how we produce and consume plastic? The researchers' call for global action is clear, but the path forward is far from straightforward. What do you think? Is this a problem we can solve with better science, or does it demand a fundamental shift in our relationship with plastic? Let's start the conversation.